So we're doing the opposite of de Moivre's theorem to find solutions to a complex number to a power. Okay, so we're like square rooting it essentially. Finding the root or, yeah. Oppositing it. Okay, so your goal is to determine and examine the nth roots. So usually the roots is given by the letter n. So you could have z to the power of 3. Then it has how many roots? 3. The solutions modulus is what? So we've got it in z squared. We want to get it to z. So we do this to the modulus. So the modulus is everyone okay? You're still recovering. And so the solutions modulus is 3. Yeah? The arguments are a little bit more complicated. So we want to find the arguments theta. Or does anyone know what that Greek letter is?
It's a lowercase theta, right?
Phi. So we put this one in here. We do plus 2k pi over n. For n, what is n for this one? 2. Okay, so this becomes 2 pi over 6 plus k theta. So now that we have a general solution, we use values for k. So in this one, there's 2 solutions because n is 2. So you always start at k equals 0. Okay? So what do we do next then? K equals 1. So now phi is pi over 3 plus pi, which equals 4 pi on 3. And we want it as that, I forgot the name of it again. We want it between negative pi. Does anyone remember what that's called again? The principal argument, there it is. So the principal argument is negative . Very good. So we take this away from. What is that about?
Because it was like each week. So they were quoting.
Why doesn't k go to 2?
Oh, sorry, I thought it was a trick question, like a joke.
No. It's only got 2 solutions, so if we go, it's like on the Argand diagram, it's like that, then that, and then we go back to that again, because it just keeps repeating itself. It's a circle. Well, that's what I'm going to do. So z cubed is now, or in other words, in Cartesian, it's 1 plus 0i. Yeah? In polar form, what would that be? 0. 1 says 0. Okay, so using those steps again, the cube root of 1 is 1. But what does phi become? Let's go back to this table. 0 plus 2k pi over n. And what's n? Same steps, we are finding, whoops, that should not be a cube up there. We are finding the different arguments. So let's go k equals 0, which is z1. 1 is 0. K equals 1. You guys can do this one for me. 1 is 3. Very good. K equals 2. So 4 pi over 3, which is the same as negative 2 pi over 3. So we've got the solutions in polar form, like the example asked. Now it wants us to put them on the polar grid. If you want to look at them, so it should go, the difference between them is the same. So they're all separated by what? 2 pi over 3. So on here, you write down Z1, Z2, and Z3.